Hello. So the problem that we're going to be solving today is climbing stairs. This is a classic easy dynamic programming problem that we'll be looking at. So let us read this problem. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one step or two steps. In how many distinct ways can you climb at the top? So now the given example is input n is equal to 2 and we have two options. That means we can either take one step, that is one step to the first step and one step to the last step, and we can directly go to the last step by taking two steps. So one step plus one step and two steps. So let me give you a more comprehensive example. Here we have n is equal to 5. That means we have 5 steps. So how many possible do we have? How many possible ways can we climb the top? So we can take one step, one step, one step, one step, one step. That is one. Then we can take two steps. We can step one step. We can take two steps. That is one more. So there are many possibilities here. So what is the first thing that comes to my mind? The first thing that comes to my mind is that I can solve this recursively. Like I can pick this stair, I can pick this stair, I can pick this stair. I cannot go here, right? So the first thing that comes to my mind is I have to start climbing the stairs, right? So how will I climb the stairs? So let's say right now I am on the ground. That means my remaining number of steps is equal to 5. Then I can take one step or I can take two steps. So this is the decision tree that I'm drawing. And here I'll take one step, I'll take two steps. So my remaining steps would be 4, my remaining steps would be 3. Then again I can take one step, that means my remaining would be 3, or I can take two steps, that means my remaining would be 2. Here again the same thing, remaining would be, I can take one step, I can take two steps, my remaining would be 2, remaining would be 1. Then from here I can only take one step, because if I take two steps I will be out of the ladder. That means I take so if I'm following this decision tree, I took two steps, then I took again two steps, and then I took one step. Because if I take two steps I will be falling down. Oh my god, that would not be great to fall down the stairs. That was a joke. Anyways so I will just be taking one step. So when my remaining is equal to 0, I will count that. So I will count that as one condition. So we can use the pick not pick logic here. The very brute force that this is what came to my mind. So basically we can count each possibility, and then collect it if it is right. Like if my remaining reaches 0, I will change my count, I will change my result to +1, right? So yeah, again if I go from here, I can take one step or I can take two steps. I can take, my remaining would be 1, remaining would be 0. So again, yeah, so basically if you can see is that from every step, let's say here from every step you only have certain number of possibilities to reach the top step, right? So from step number 3 I can either go here and here, or I can go here. So there are only two possibilities from step 3. So there is no point in calculating all of this here when I have already calculated this here, because if you notice, this whole same thing is gonna be made here as well, right? This whole wrong thing that I've made here is the same, essentially the same, right? So there will only be so many number of steps from a given point, right? So why not we save this, right? So basically, if the code, the very brute force code that comes to my mind here for recursion would be ki I have a function solve wherein I pass the number of steps that are remaining, and if my remaining became 0, if my remaining became 0, I would return a 1. If my remaining became less than 0, that means it crossed here, right? If my remaining became less than 0, then I'd return a 0. And then I would, if not, if all no both of these conditions are not true, then I would retain solve remaining -1 plus solve remaining -2. That means I took 1 step, I took 2 steps. So essentially what we are doing here is that I'm recursing this by taking 1 step, 2 steps. So here I am calculating. So if finally so I'm taking 1 step here, then after taking 1 step, what are the number of possibilities after taking 1 step? What are the number of possibilities that are here? That is what I get from here. And after taking 2 steps, what are the number of possibilities? What are the number of possibilities after taking 2 steps? That I'm counting here, and both I'm adding up and I'm returning, right? So this is the basic brute force. You can run it down on your own. And yeah, so now the better approach, now I made you all see ki I'm repeating this whole thing here also, right? So we can cache it. What comes to my mind? Dynamic programming. I can save this already, right? So if you see dhyan se, from phi to reach phi from phi, there is only one possibility, or in that case, to reach the nth step, there will always be a one single possibility, because you cannot go ahead, right? So this is what I observed here, ki to reach the last step there is only one possibility. Then to reach the last step from the second last step, again one possibility, because if you take 2 steps you will fall out that you don't want. So here it is always 1. Then from here, what are the number of possibilities to reach the top? 1. So I can write 2. Then what are the possibilities from here to reach the top? From here, or here, right? So this is one possibility, this is second possibility, and this is third possibility. So it is 3. So if you see very carefully, you're essentially adding these to get here, right? So from the step below, there are only the number of steps to reach the top is essentially the sum of the number of ways to reach the top from the next 2 steps. I repeat my statement. The number of ways to reach the top from a given position is essentially the sum of the number of ways you can reach the top from the next 2 positions. That means ki from the 3rd step to reach the 5th step, last step, the number of ways is the next 2 steps ka sum. So 1 plus 1. Now basically here you can fill the DP table, like let's say you have a DP table here. Let me take all of this down. Anyways, thoda hil gaya. here let me make this dp table, right? So I'll initialize these as 1, I'll initialize these as 1 and 1, right? And then I'm adding these two here, I'm adding these two here, I'm adding these two here, and I'm adding these two here, right? So 3 5. So my number of ways to reach the top is 5, right? How are we gonna do this? We're just gonna take a loop, and we're gonna add these two numbers, or add the next two numbers into this, right? So that is essentially what we're gonna do, and then we're gonna return this number, because that is our answer, right? This is what we're gonna do. Now this would take O of n space complexity, but if you see, we're basically keeping track of just two variables, right? We're taking this variable, we're creating a new variable, and we're adding these two, right? So we can just do it in two variables, a and b also. So let's just go to coding that given problem. So here, let's code this up. So int, we've been given an integer n, then int a is equal to 1, int b is equal to 1. What was this? This was essentially our these two. These were our these two. So int a is equal to 1, b is equal to 1. We initialized the last two stairs. Then I just have a loop, int I is equal to 0, I is less than n, I is less than n, I plus plus. Then I have a is equal to a plus b, and b is equal to temp, right? Temp is equal to a is equal to a plus b, and b is equal to temp, right? And then finally we're gonna be returning a. Now what just happened here? So let's say this was my a, this was my b. So here I store the value of a inside a temporary variable, and then I add these up, make this a, make this b. Did you get that? That's what we essentially did, right? So let's just go and hit submit, and hopefully this works. And a wrong answer. That is good, that is very good. That is because this should be n minus 1, because when you see when you do less than 1, because we're starting from here, right? We're starting from here, we have to only go these many stairs, we have to not go the entire thing. So that's why it happened. Yeah, so that is our solution. Thank you so much for watching.